Narrator low, tense, cinematic. What if I told you Mars isn't silent? What if the dry, frozen world we thought we understood has been hiding electricity in its storms? Not thunder, not lightning as we know it, but something stranger, smaller, and far more mysterious. NASA just confirmed miniature lightning on Mars, tiny electric sparks crackling inside dust devils and storm clouds. A discovery that changes what we know about the red planet, and what may one day threaten astronauts who dare to step on its surface. Today, we dive into the most surprising Martian discovery of the decade, and the shocking truth of a planet that might be more alive than we ever imagined. Welcome to AED, the unexpected voice of a silent planet for decades. Scientists describe Mars with one phrase: cold, quiet, dead. A planet with no thunderstorms, no rain, no roaring skies, just dust. Endless dust. But on a lonely afternoon, across 95 million kilometers, a rover sitting inside a crater recorded something that was never supposed to exist. A crack, a spark, a whisper of electricity. The Perseverance rover, designed to collect rocks, search for ancient life, and map the terrain, had accidentally stumbled upon something completely different. The planet's hidden electrical heartbeat. NASA didn't believe it at first. Even the scientists doubted their instruments. Mars wasn't supposed to do this. But after 2 full Martian years, over 28 hours of audio and electromagnetic recordings, the truth became undeniable. Mars has lightning, not the kind that splits the sky, but mini lightning, born from dust storms. And if there is electricity in the air, then the planet's atmosphere, climate, and chemistry are far more dynamic than our models predicted. This is the beginning of the story. The first signs of a storm, the discovery began subtly. The Perseverance rover was parked near Jezero crater. Winds kicked up dust devils, small spinning columns of dust common on Mars. Scientists monitored them for environmental studies, but soon, the rover's microphones recorded something unusual: tiny crackles, faint pops, micro explosions of charge, static electricity, loose signals. Instrument errors. NASA's team wasn't convinced, so they dug deeper. The rover's supercam microphone, normally designed to capture laser shots hitting rocks, picked up bursts of electromagnetic noise. At exactly the same moments, dust devils passed overhead. Not once, not twice, but eventually, 55 separate electrical events. This wasn't random. This wasn't noise. This was physics. Dust grains rubbing, colliding, charging, then discharging as electric sparks. Mars wasn't dead. Mars was electrically active. How dust creates lightning. On Earth, lightning forms from massive clouds, water droplets, ice particles, and powerful vertical winds. But Mars has none of that. So how does lightning happen? The answer lies in something surprisingly familiar: static electricity. Visualize this. You shuffle your feet on a carpet. A spark jumps to a door handle. That spark is electricity released after friction. Now imagine that on a planetary scale. Mars is covered in fine, dry dust. Dust devils lift this material tens to hundreds of meters high. Each grain collides with the next, transferring electrons. Energy builds, charges separate, until finally, snap. A micro-lightning discharge. Invisible to cameras, but loud enough for sensitive microphones and powerful electromagnetic sensors. These sparks are small, fractions of what we see on Earth, but their meaning is enormous. Mars has an active electrical environment, which means its dust storms are far more complex and far more dangerous. Why NASA is shocked for NASA. This discovery creates 3 huge implications. 1. Dust storms are more powerful than we thought. Lightning affects how storms grow, merge, and travel. Even tiny sparks can influence dust movement. 2. Chemistry on Mars could be changing. Electricity can trigger chemical reactions. Sparks might help form hydrogen peroxide. Ozone nitrates. These compounds could influence atmospheric evolution, or even the ancient potential for life. 3. Future astronauts face new risks: suit electronics, life support systems, habitat wiring, power grids. Even small discharges can cause malfunctions in a place where survival depends on every piece of equipment working perfectly. Mini lightning may sound harmless, but on Mars, even a spark can be deadly. The science behind the search Perseverance detected the sparks using SuperCam microphone captures tiny acoustic signatures. Electromagnetic sensors pick up bursts of static discharge. Environmental monitors track dust. Diverse pathways. Scientists analyzed pressure drops, wind speed, dust density, audio crackles, bursts. Every piece of data matched the profile of electrical discharge. This wasn't a glitch, it was a pattern, and patterns tell stories. The story Mars told was simple. I am not as quiet as you think. What this means for human exploration. NASA's ultimate mission is to send humans to Mars. But until now, dust storms were considered a visibility problem, not an electrical hazard. Now the checklist becomes much longer. Could sparks damage solar panels? Charge buildup could reduce efficiency or cause microfractures. Could habitats be affected? Static electricity inside airlocks or around equipment might interfere with electronics. Could astronauts be shocked? Not in a deadly way, but enough to disrupt suit sensors or tools. Could lightning impact landing? Storm-induced electrical fields could interfere with landing systems. Mini lightning forces mission planners to rethink every step. Mars may be colder than Antarctica, but its electrical personality is far more unpredictable. The greater mystery: has this always been happening? Scientists now ask a deeper question. If Mars has electricity today, did it have it billions of years ago, when Mars was warmer, wetter, and possibly home to life? Did storms carry electrical energy similar to early Earth? Could sparks have driven chemical reactions that create organic molecules? Could mini lightning be a clue to Mars' ancient biosignatures? This discovery opens a door into Mars' past, and maybe into the history of life itself. The dust storms of today might be echoes of a wilder, more energetic world. What comes next? NASA plans to send more sensitive instruments, record actual images of electrical discharges, build models of storm electricity interaction, redesign astronaut equipment, update hazard predictions. Future missions may carry high-speed cameras capable of capturing the sparks visually. Because right now, we have the sound and the electromagnetic signatures, but not the light. The final proof is coming, and when it does, the world may see Mars as it truly is. A planet with fire in its dust. Takeaways. 1. Mars isn't dead, it's electrically active. A tiny spark tells a big story. 2. Dust storms are more dangerous than imagined. They don't just block sunlight, they release energy. 3. Human missions must prepare for electrical risk. A new challenge rises from the dust. Mars has always been mysterious, but today, it shocked us. Literally, a world once believed silent revealed its hidden pulse. A spark inside a storm, a whisper of electricity across an alien sky. As NASA prepares for humanity's most ambitious journey, every discovery rewrites our expectations and reminds us that Mars is not waiting quietly. It's speaking, crackling, charging, preparing, and as always, we're here to uncover the truth behind every cosmic surprise. Thesis I did, where the universe speaks and we listen.